increase in data. So we need new technologies both to compress data, that's one part of data being transported, but also we need a new network, and 5G is the answer to increasing the capacity, but 5G is so much more. So what is 5G? So I guess this is just a quick graph that every 10 years, every decades, we have had a new generation in mobile telephony. So we started off with analog systems in 1980, and then we had the first digital systems, 2G systems, that was 1990. 3G came around 2000, 4G came 2010, and now we have 5G coming up this year, or actually they start getting more deployed next year most likely. So what is the time plan? So 3GPP is the main organization specifying 5G. And we have different drops, or in the 3GPP language it's called release 15 or release 16. So release 15, they had a drop last year in June 2018, and that was the first 5G standards. They were ready, and we call that the phase 1. So it had the new radio, new 5G core, network slicing, and edge computing. These are the main areas. So 3GPP is right now working on a second release, and that will be released at the end of this year. And that is the main focus is wireless and wireline convergence, and also ultra-reliable low latency communication. But there will be more in 5G in release 17, and one of these aspects that we're working on right now in 3GPP is, for instance, how to use 5G for audio-video production, live AV production. That's one of the topics for release 17. So 5G is really, we call it a common network platform that enables the ICT transformation. So we have one architecture supporting multiple industries. So with one architecture, we can support automotive, we can support broadband, television, we can support IoT, interoperability of things, Internet of Things, sorry. And this is done by a lot of the network is virtualized. We have software-defined networking. The network is mostly done in a distributed cloud system. And this is the concept of network slicing. So you can define parts of the network to your specifics and characteristics. One of the core features behind 5G is a new radio. And this is just to say that the old LTE or 4G, that's still part of the 5G system. But we are extending the new radio. And first we have there is a gradual transition into the old spectrum that is used today for LTE, but there is also a new spectrum for 5G at higher frequencies. But 5G will be the whole solution. So let's talk a bit about media. So 5G for media. So sometimes we say that 5G drives media, or media drives 5G, because media is really the main content. As we saw, 73% of all mobile traffic will be video in 2023. So media is what drives all the traffic in these networks. So some of the key aspects for media. So for instance, VR and AR, this is what this session is about, immersive media. They rely on new concepts or improved concepts for 5G. And one is a very low latency. And combining that with edge computation, you can do a lot of offloading from devices that you can do close to the device, but in the edge, in the network instead. And this is important for conserving battery life, for instance, if you have a head-mounted display, in particular for an AR device where you need to do lots of computations. Network slicing, I mentioned that already. This is how to define parts of the network to your characteristics. Fixed wireless access, 5G is used to deliver media in new areas or in places where it's difficult to deliver internet or broadband today. So this is a way to deliver to rooftop antennas and then have access in houses. And also hybrid. With 5G, you can combine it with normal high power, high tower networks, so that you can have a long tail over 5G. You can hybrid solutions. So this is also one of the areas where we see 5G can complement media distribution. So some numbers. So 5G redefining the media landscape. So these are just numbers, but we say that typically you can get 1,000 times higher data volumes with 5G compared to 4G. 5 times lower latencies, and for 5G we're talking latencies down to 1 millisecond in the network. 10 to 100 times more connected devices, and this is important for Internet of Things, where you have lots of small devices, for instance temperatures or other sources that sort of want to, so thermometers or other sources, video cameras that be connected over the internet. And battery life. So 5G supports modes where you have really low battery battery consumption. So for instance, if you have an IoT device that very rarely sends a specific update, then you don't want to change the battery all the time. But so the 5G, you can have devices that's up to 10 years lifetime on a small battery, and these are typical IoT applications. So, what are the new things or what we can improve with 5G? Mobile broadband expansion. It really makes it easier to increase the capacity for consumers. Enhanced viewing. So these are some examples: ultra high definition or AR and VR. Fixed wireless access. This is solutions for hybrid access in the homes. And also new opportunities. So here we mention, for instance, infrastructure for content creation, also uplink for AV production, to remove SDI cables and do camera uploads over 5G to an OB-WAN, and then up to a distribution center, so you can have really high data rates over 5G. So I haven't been stopped yet, I have a couple of more minutes. So I just want to then mention some of the applications where 5G is being used. So for instance, virtual reality is already standardized by 3GPP. So this is a news article from October last year, just announcing that 3GPP now supports VR in the 5G standard. So that was finalized end of last year. And for virtual reality, we have one of the experts here in the room, Rob Kernan, working a lot on how to deliver 360 video to a mobile or to a head-mounted display, and using techniques to only send parts of the viewport. And this is supported in the 5G standard, in the 3GPP standard. And so really, in order to do this, you need to have a very high bit rates, or you need to be able to select parts of the viewport and with a very low latency change to what is viewed by the person in the head-mounted display. And these are two very good examples of how 5G can be used for supporting a new use case. And if you happen to be in Culver City, Los Angeles next week, there will be a workshop on this topic, Immersive Media Meets 5G. And this is a collaboration between 3GPP and the Virtual Reality Industry Forum and the Advanced Institute of Advanced Image Society, sorry. Augmented reality. So this is also immersive media. And here we have two use cases. For instance, you can have an industry application where this is something that we've been working a lot in Ericsson. We call it an assistant that can help you guiding when you are supporting or servicing equipment. So in your AR glasses, you will get directions how to, where to change things if you're doing service. And another example here is image analysis. For instance, if you have an AR goggle and you walk in the street, maybe you can do object identification and enhance that information in your glasses. And why is 5G good here? First of all, it's truly mobile. You don't want to be connected when you walk around in the city. You want to have a head-mounted display that is connected only with 5G and not the cord. So first of all, you want to have a wireless standard. You want to have a device battery that lasts. So you want to put computations in the cloud or on the edge and not in the head-mounted display. You want to have low latency so that when you move your head, you quickly adapt to the new views that you are seeing. And also high bit rates. This is also something that 5G supports. So all of these factors are really talking in favor of using the 5G standard. And my last example is live audio-video production. And this is something that is not standardized yet, but there is a lot of discussions right now in 3GPP, and there are also working groups in the EBU on use cases for how to replace the SDI connections or the standard over SDI with a full IP. And this full IP you can then put over the 5G standard. So there is a standard from SMPTE 2110, but then how to put that over a mobile network, that's really what's happening in 3GPP and EBU now. So we want to remove camera, fibers and cables and put it over 5G. So this is one of the use cases that is now input in the standardization process, and this is done in release 17. Right now there's a study on how to use AV services in 5G, and that study will be finished in June this year. So this is the status right now in 3GPP. Okay, so that was my last slide. So thank you so much, and I will give the microphone to Richard.
Thanks very much, Per. So we will move to Richard Mills, who is an expert in immersive media. He's done a lot for Sky, and he will tell us how he thinks 5G will make his life better, easier, more productive, and the life of consumers, I think. Thank you.
Yes, good afternoon, everybody. Hopefully we'll give you an overview of the work we've been doing at Sky and how advanced networking will help us. So, Sky VR was formed in April 2016 as an experiment, basically. We were the first UK broadcaster to aggregate content and to produce our own and deliver it in an app to our viewers. We've produced our own content, and we've also commissioned outside work as well. And the whole idea is to create entertainment and also engagement. So we've covered a variety of genres, from sport to entertainment, documentary and news, and also drama and entertainment. And you could say generally that the content we produce is allied to the main TV content of the many channels that we output. So what should virtual reality achieve? Basically, you should design a unique experience, especially designed for VR, not try and shoehorn another format into VR. It should have credible immersion within the environment. You should also have a true sense of being there in the virtual environment. And best of all, involve the viewer in the action. So give the viewer some form of agency over the content and be able to navigate through the content and interact with it. Very important to us was market research. It's important to find out what our viewers want, how they commented about the material, what they enjoyed and what they didn't enjoy. So a lot of market research went on, a lot of hundreds and hundreds of people being subjected to VR, enjoying VR and getting their feedback. The feedback was really that original content, something that was original, novel, something that was unique, was like best of all. If we produced some content that was related to our main broadcast streams, this was also very popular. It could be an additional story, it could be additional content related to a particular drama series or to sporting events. And so we looked at the kind of work we were producing and determined which were the favourite genres that people liked. The other aspect of it as well was to make sure that we were providing something of a technically high standard. The quality of experience was very, very important to our users. They wanted the best playback quality, they wanted high resilience, they wanted a comfortable experience. In other words, being in a headset for more than 10 minutes wasn't painful, it didn't annoy them, and it didn't make them feel uneasy. The less fiddly the better, so no complicated menus to get in there, and long battery life and low heat. So the type of content we produce 360 video by shooting with multiple camera arrays, stitching it together and outputting it. We've used volumetric studios, volumetric capture, to capture performances by artists. We've also used photogrammetry and scene scanning to generate or capture environments and objects. And we've used character scans and motion capture and animation to animate scanned characters.
Richard, could you hold the mic a little closer? It's very much here.
Okay. So these assets for virtual volumetric capture and scan capture can be used in VR, AR, and they can also be used in traditional broadcast as well. As an example here, Anthony Joshua, the boxer, we captured him in Microsoft's Dimension Studio in London, shooting at 120 frames a second, so he could really move fast. You could get the impression of the speed of his actions and punches. This was the result produced, a photorealistic virtual character that you could walk up to. We used it in AR on the Sky Sports app, but also in virtual reality in a room scale production as well. So how do we achieve this optimized playback? We need low latency. We need, when the head turns in the headset, we don't need any lag. We want a refreshing of the picture instantaneously. We want a high frame rate and low latency. The deployment of 5G will help us. We now already are starting to get the deployment of the Snapdragon 855 in handheld devices and also in headsets. It enables VR, AR and mixed reality on a variety of devices. Coming up shortly, there's Zenreal, which is tethered to a 855 powered smartphone. We also have the HTC Cosmos, Vive Cosmos coming out, which again is 855 Snapdragon powered. And we also have as well a very interesting device here, a home 5G repeater. So if you've got 5G outside, this will repeat and provide high bandwidth inside the house, getting ready for your mobile router. So optimized playback, how does that work? We had a little bit of discussion from Per, but we'll go into it in a bit more detail. So field of view adaptive. So basically you have a headset, head-mounted display. You've got some master content, which you image subdivide. You have positional metadata from the headset, and a cloud view rendering server. So as the headset moves, you call down a particular view in real time and then serve it. This obviously has to be a very, very low latency procedure. And this is how we do it. So you take it's a 360 video example, not necessarily game content, but it would work exactly the same for game content. You subdivide it, you generally project it as a cube rather than spherical, subdivide it, and then subdivide that again into tiles. You then, from the headset, you serve the relevant tiles required. And if you look here, we've subdivided 96 tiles, and we've served generally about 32, so you're getting a 3-to-1 reduction in bandwidth immediately, which you can put into higher resolution and lower latency. Another couple of examples of work we've done using volumetric capture. This is a room scale 6 DoF experience with David Attenborough. It enables you to visit the Natural History Museum inside in London and view and pick up the exhibits as well, which have been scanned faithfully by the Natural History team. Another one here. This is a 6-DoF room scale experience based around a drama series, very popular with our viewers. Enables you to follow a part of the story which isn't in the main series. You're allowed to roam around the Bodleian Library in Oxford and pick up clues and interact with two main characters. You're embodied as one or other of the two main characters. Curfew, which is a futuristic, apocalyptic Britain visited by zombies, and your only way to escape is in a car, so it's a driving experience in a car to escape apocalypse. And that's it for me. So it's been an interesting ride, and the lessons learned are the most important thing, and high quality, low latency, quality of experience which 5G will bring to us.
Thank you, Richard. Maybe because we have some time left, you could talk a little bit about the role of 5G to play in production of content. Is that something you can talk about?
Yes, absolutely, yes.
Yeah.
So Per mentioned that you can do remote production potentially with 5G. I know that BT Sport in the UK have done an end-to-end 5G iteration. So that's 5G at the venue. It's a fibre backhaul to broadcasting station, but basically virtualized cameras on location going back to a remote production hub and then being broadcast from there. That's one version which Per's taken us through. The other very, very interesting thing as well is fast turnaround content. If you've got news content, you don't necessarily have to go out live, but you need to be able to upload in difficult locations, remote locations, and work on the content and then fast turn around and put it out. This is probably an ideal use case. We think that 5G networks have high bandwidth, yes. They also have millions more connections per cell than 4G, but also as well, they have very, very fast cell-to-cell switching. So if you're driving back from a location, you could be going in the right area with the right iteration. You could be passing rushes back, editing in a vehicle whilst driving, on a train, and passing that stuff back to base to be edited, whilst moving on to the next job. That's another example. So another thing which is an interesting facet, which I've been working a little bit on, is I've done quite a lot of wildlife filming over the years. And what's very difficult is catching the moment of wildlife filming. You have to camp out for ages, hours, you have to hide, and you don't know necessarily where to go to find an exotic animal or a particular behaviour. Most natural history filmmakers like to try and discover something about an animal that's unheard of, unknown, and then try and film that. So a previously unseen behaviour. So with the massive machine aspect of 5G, so a large number of low power, wide area network connected devices, you could have camera traps out in the area which could count. They could send you a thumbnail back if something passes in front of them, so you can get a better idea. These are very cheap devices, battery life of months or years, send you back data so you can get a good idea of habits of the wildlife in that area, or picking up some particular aspect of wildlife that you might want to focus in on.
So we need to wire up the jungle.
Well, the British countryside is already pretty well wired up. River levels are measured using IoT devices. It's used for measurement of pollution. All we do is we're extending a little bit further and using the high latency wide area network.
Nice. So I think we may have room for one or two questions. Are there any questions in the audience? There's a microphone there. Anybody? There were questions yesterday. Richard, do you think your presentation could be made available? Is it
Yes, I think that probably NAB is going to publish it afterwards. I've sent in a PDF version.
okay?
Yes.
Okay, good. Because we were planning on making them available on the VRAF website.
Yes.
So all three presentations, both Paul's both Paul's presentation from yesterday, Pier's presentation, and yours. So they will be made available, the presentation, shortly on the VRIF website, vr-if.org, and where you can also read about the workshop that we will have next week in Culver City. So if there are no questions,
Right, question.
yes, there is a question.
Yeah, I know that.
Do you want to stand up by the microphone?
Okay.
So
Just
people can hear you, yes.
take one of these.
All right. Yeah, hi. I know that your company is one of the best 5G technology company in the world. Yeah. So I would like to know, what's your status? Your company helped some U.S. company to implement 5G infrastructure, right? Like Verizon. So what's the new status? When we can see the real result? We can use your 5G.
Okay, so probably Per's a better one to answer this, but the rollout depends on putting network infrastructure in there. So as far as I know, at the moment, some bits of Delaware and Florida have some 5G network that's almost ready to roll out. In the UK, there are very small pockets of it for experimental purposes, but I'm not sure. It'll be 2019, end of, beginning of 2020 when it'll start rolling out in the UK.
Good, thank you.
Per, do you have anything to add?
I don't. I mean, I think that was a good answer from Richard. So I'm from Ericsson, and we are rolling out. We have many contracts going on, but it takes some time. I mean, but it's happening this year, but more next year. I don't have any details really. I'm a standard guy, so.
And we do have some 5G capable devices out there already. A couple of phones which are 5G capable, but that technology will roll out as the networks become more and more available.
Okay, thank you very much for coming to the Destination 5G. This was the VRF production. If you're interested in our workshop, look at the screen next week. 2 days of 5G and immersive media. So worth it. Thank you very much.